This is Mrs. O'Neill for Chapter 2, Section 2, Mixtures. And I want to remind you about reading the book. It's not necessary, it's not mandatory, but as you are doing the book work, if you get stuck, you might want to read that section. So in this section, you're going to be able to categorize a sample of matter as a substance or a mixture. So you're going to be able to distinguish between homogeneous and heterogeneous samples of matter. In 1848, gold was discovered in California. This discovery led to a massive migration or rush of people in California. Panning is one way to separate gold from a mixture of gold and materials such as sand and gravel. A pan containing the mixture is placed under water and shaken vigorously from left to right. This motion causes heavier materials such as gold to move to the bottom of the pan and lighter materials such as sand to move to the top where they can be swept away. In this section, you will learn how to classify and separate mixtures. Really, to classify, there is a section about filtration and distillation that we're not going to discuss, so you're not going to have to worry about it. So again, pause the video, fill in the blanks, and then play to hear my words. So a mixture is just a blend of components, right? It could be 2, it could be 3, it could be 4. If there's a blend, if there's more than 2 things that are mixed together that are not pure, right? If you have different kinds of atoms or different kinds of molecules that are mixed together, then you have what's called a mixture. So heterogeneous mixture means that the composition, okay, the stuff that it's made from, is not uniform throughout. They are usually solids, but not always. And I like to use food as an example, right? When you're eating your chicken noodle soup, you don't have every bite exactly the same. Some might have noodles and carrots. Some's going to have noodles and chicken. Some's going to have noodles and celery. So every bite is slightly different. So if I were to take 2 chunks of that or 2 areas of that chicken soup, I'm not going to have exactly the same thing. That's what it means by composition is not uniform throughout. However, homogeneous mixture is composition that is uniform throughout. It is usually a liquid, and when we talk about liquid homogeneous mixtures, we're going to refer to them as solutions. So again, I like to use something like Kool-Aid. When you take your Kool-Aid mixture and you put it into water to dissolve it, from the very first drop to the very last drop, it all tastes the same. So that means that it is the same stuff throughout. It's going to be the same particles throughout. So here's again, I like to show you those visuals on the molecular level. So here's a homogeneous mixture of salt and water, and here's a heterogeneous mixture of salt and water. Now what I'm really trying to show you here is this is nicely dissolved. The salt is nicely dissolved in the water, so it's kind of dispersed throughout. But at some point, and we're going to talk about this later, you have a supersaturated solution. And when you have a supersaturated solution, that means some of the salt is going to kind of lie on the bottom. It's not going to be able to dissolve. And that way you would have a heterogeneous mixture because you would have your salt water on the top, but then you would have salt kind of laying on the bottom. And so then that mixture would be considered heterogeneous because the components throughout are not the same. So let's do some practice problems. Can you distinguish between these 4 things? Which ones are going to be homogeneous, which ones are going to be heterogeneous, and the why. Why is it homogeneous or why is it heterogeneous? So pause the video, see if you can come up with your answers, write them down, and then play the video to check your work. So for number 1, granite rock, again, think about taking 2 sections of that granite rock. Is it going to be exactly the same? No, so that's why I put heterogeneous. One part of the rock might have more pebbles, one part of the rock might have more glass. Yes, there's usually glass in rock. One part is going to maybe be like more of that like really, really hard clay. So I'm going to say that's heterogeneous. How about salt water? Well, we just talked about that. That's homogeneous because as long as I don't oversaturate it, from the first drop to the last drop should taste the same. How about paint? Well, paint is a little bit different. It depends on your perception. If I think about paint, I think about the fact that I actually have to mix it before I use it. Or were you thinking like paint on the wall? And paint on the wall should look exactly the same from one area of the room to the other area of the room. So it depends on how you look at it. So not everything, unfortunately, not everything is pure black and white. There are going to be some gray areas. But that's why I asked you for the why. If you can tell me the why you thought it was heterogeneous or the why you thought it was homogeneous, then as long as your explanation or your reasoning matches up, you'll be fine. How about a silver ring? Well, I don't know about you, but silver is an element. And if silver is an element, that's actually, silver's an element, but the silver ring would actually be an alloy because it's a mixture of metals. It still would be homogeneous because it's the same throughout. So just like that example we talked about before, or I showed you before, steel. Steel is an alloy. It's a mixture of metals. Those would be considered homogeneous. It's the same throughout. So you ready for that little quiz? So again, read, pause, I should say pause, read, try to answer. Hopefully you got that. Hopefully that makes sense. And we'll see you in class.